Welcome back to Calculus with Mr. Walton. Today we're in section 5 of chapter 6. That's logistic growth. We're first going to start out with a partial fraction decomposition to make sure that we remember how to do this. So, write the function as a sum of the rational functions with linear denominators. Alright, so you see this first. Think it through, you guys try it, and you'll see some solutions in just a second. Ready and go! Alright, so first we're going to factor our denominator. Then we're going to rewrite with a and b since we have two factors. Then we're going to multiply everything by our LCD, which is x squared plus 5x plus 6, or factored form x plus 2 times x plus 3. Then we're going to let our x values be negative 3 and negative 2 so that we can cancel out and get zeros so that we can find our a and b values. And finally, we're going to use those values so that we can rewrite our function f of x. Instead of being 3x plus 11 over x squared plus 5x plus 6, we can now say that it is 5 over x plus 2 minus 2 over x plus 3. Moving on to example number 2. All right. What I wanted to do, anti-differentiation with partial fractions. Look at this problem. Woo! What could we do to make it simpler? Let's use our partial fractions. All right, you guys try it, and you'll see an answer in just a second. All right, so we factor, we set up, we multiply by the LCD, we use x equals to 5, x equals to negative 1/2 to find our a and b values. When we do so, then we're able to integrate, and we are able to simplify and get our final answer. All right. Looking at this, we cannot combine these natural logs unless we do an extra bit of manipulation, so we leave it. Let's move on to example 3. What if I ask you to find the general solution by using partial fractions for this one? So now we're going to have 3 parts, an a, a b, and a c. So we're going to have to solve it the long way. All right, so you guys, you could set this up, try it out, and you'll see my solution in just a moment. All right, so again, we're going to factor. We're going to set up our a, b, and c over our denominators from our factors. We're going to multiply by the LCD. We're going to set x equal to 0, x equal to 1, x equal to negative 3 to solve for our a, b, and c numerator values. Then we can say that dy dx is equal to negative 2 over x plus 9/4 over x minus 1 plus negative 1/4 over x plus 3. And then we're going to integrate. If we integrate appropriately, hopefully we get this beautiful, lovely solution. Y is equal to negative 2 ln of absolute value of x plus 9/4 ln of quantity x minus 1 minus 1/4 ln quantity x plus 3 plus c, because it's our general solution. All right, next up, logistic growth using logistic regression. The following table shows the population of Laredo, Texas for selected years from 1950 through 2003. All right, so we have this value, got our setup, and for A it says use logistic regression to find a curve to model the data. Show your scatter plot and equation on the same graph as well. All right, so how do we run through our calculator to do this? We're going to come over here. Step 1. Okay, we're going to put our data. Okay. Then, after we've input our data, we're going to add a sheet. Now, this is through a brand new document. Again, in step 1, we're going to go new document, and we're going to grab our spreadsheet. Then for number 2, after we've put our data in, we want to create, hopefully you guys can see that number 2, data and statistics. It's going to go to the top where it says unsaved. We're going to go to number 4, insert data and statistics. And we're going to have this number 3 show up. We're going to click down here where it says click to add a variable, and we're going to click A. When we do, it'll look like we see a number 4. Then we're going to click over here, and we're going to click on B. Once we click on B, it's going to give us a beautiful, lovely curve like this. And then we're going to pick our menu. Okay, so now we're Step 5, we're going to pick our menu. Once we get to our menu, we're going to actually go to Analyze. Okay, from Analyze, we're going to be here at Regression, which is number 6. This is number 6. It's hard to see. And we're going to say Show, but it's not not logarithmic. It's Logistic. So down here, we're going to see Logistic, and we want D equal to 0. And when we do that, it will graph for us right here and give us our equation. Awesome. Hopefully this makes sense for the most part, but at least you have an idea of what we're going to do. This is our last step, and here is our equation right here. So now we'll come back over and we'll write this in. Okay. So we have our population equation now. Boom. Then it says for part B, based on the equation, what number will the Laredo population approach in the long run? Okay, so in the long run, that means we're looking at P of infinity. So let's let the limit as t approaches infinity of our quantity, 232,740 over 1 plus 14.582 e to negative 0.101 times, we're going to put that infinity in there, and this goes to 0. So if that's true, I have 232,740 over 1, so I should get about 232,740. All right. Then part C says, when will the Laredo population first exceed 225,000 people? So we're going to set up our equation to show that 225 is the population in which we are interested, with our 232,740 over 1 plus 14.582 e to the negative 0.101 t, and we want to solve for t. Now if you use your calculator, you should get t is approximately 60, and that's from 1950, so the year would be 2010. 2010. And last, we want to write dp dt in terms of k times p times m minus p. So easily enough, we just have to figure this out. All right, and we can plug it in. We've got our beautiful dp dt is equal to okay, we solved for our k. We've got our equation. We're good to go. All right, that's 6.5 logistic regression.